So what if I told you that the future of, like, blockbuster video game development isn't a massive studio, not a building filled with 500 exhausted engineers pounding energy drinks at 3 a.m.
Right. Yeah, the classic crunch time image.
Exactly. Instead, I want you to picture this. You are standing on a beach in Cape Town. You can feel the wind coming right off the Atlantic Ocean. You turn around and there's the iconic flat-topped silhouette of Table Mountain right against the sky.
Which is gorgeous, by the way.
It really is. And the man standing there, just taking this all in, is named Irwin. He is not at a keyboard, he's just watching the sea. Yet at this very second, an entire living virtual world is being built for him.
Well, it completely shatters our traditional mental model of, how complex software is made.
Right.
We're so conditioned to just associate massive output with massive human labor. But Irwin is out there enjoying the beach because, well, he isn't the one doing the labor.
And that is the perfect entry point for our deep dive today. Welcome in, everyone. We are exploring this fascinating source document called CityLife, the world that built itself.
Yeah, it's such a great piece.
It really is. And our mission today is to unpack what honestly feels like a massive paradigm shift. We're looking at how a single person managed a fleet of autonomous AI agents to design, code, and deploy a fully functioning, deterministically generated open-world video game.
And the kicker.
Oh, the kicker is they did it in just 27 days.
Which is just a staggering timeline. I mean, 27 days. But
Yeah.
to be clear right off the bat for you listening, this isn't just a story about some clever code or a new tech trick.
No, not at all.
It's actually a story about a completely new architecture for a software company. It's this structure where the human being is purely the orchestrator, like the CEO. And the bots are the specialized employees executing the vision.
Okay, let's unpack this, because to truly understand how someone can be standing on a beach while a game basically builds itself, we have to rewind.
Yeah, we have to go back to day one.
Exactly. We have to go back exactly 27 days to May 30th, 2026. Because the sheer speed of this genesis is, well, it's hard to wrap your head around. How did this even start?
So the initial spark actually came from a YouTuber named Wes Roth.
Yeah.
He threw out this idea, sort of like a benchmark challenge, of having AI models author their own scripts to play a video game.
Okay.
But Irwin took that seed and completely flipped the objective. He evolved his project from version 1, which he called CityMind, to this version 2, which is CityLife.
Right. The upgrade.
Yeah. He stopped asking, can an AI learn to play a simulation? And started asking, what if an AI fleet actually built, governed, and expanded the simulation itself?
So the AI isn't holding the controller. It's actually writing the game engine.
Exactly.
Let's look at the timeline of that first day, May 30th, because the velocity here is terrifying. So 9:52 a.m., the Genesis commit happens.
Right.
And for you listening who might not be a developer, a commit is basically a foundational save point in the code's history. Irwin pushes the very first block of architecture.
Just setting the stage.
Yeah. Then, less than half an hour later, at 10:21 a.m., the construction loop is working. But wait, how is an AI actually constructing anything at this stage?
Well, it's writing the programmatic rules for generation. Like instead of a human opening a level editor and clicking a mouse to place a building.
Like you would in SimCity or something.
Right, exactly like that. Instead of doing that, the AI is writing the mathematical logic that dictates where and how a building can spawn.
Oh, wow.
Yeah, it's defining variables for grid placement, collision detection, resource allocation. And it's writing and executing that logic in literally a matter of minutes.
Which totally explains the next timestamp in the source. By 11:07 a.m., the simulation has branching roads and a 3-zone split for the city.
Yeah, the residential, commercial, and industrial zones.
Right. It even has a system wiring the digital citizens to their specific jobs in under 2 hours.
And then less than 30 minutes after that, at 11:35 a.m., we see the AI do something really fascinating with context.
Oh, the road rules.
Yeah, it commits South African road rules into the simulation. The digital cars are suddenly driving on the left side of the road.
Wait, hold on. How does it decide that? Like, did Irwin explicitly prompt it, hey, build me a South African city?
Not explicitly in a single command, no. But AI agents constantly ingest the context of their environment and their user.
Okay.
The system knows Irwin lives in South Africa based on his Mermit variables. So when tasked with creating realistic traffic flow, the AI just extrapolates from the localized data it has access to.
That is wild.
It essentially assumes the creator's default reality. So it mathematically routes all the traffic nodes to the left.
It's so personal yet completely automated, and, it doesn't stop there.
Yeah.
By 8:38 p.m. that same evening, the source notes the game has continuous asphalt roads with dashed center lines mathematically draping over procedurally generated terrain.
Yes.
I have to pause here. How does code drape a road over a mountain?
Oh, this is where we get into the heavy math that AI is just incredibly efficient at. Procedurally generated terrain isn't painted. It's created using algorithms called noise functions that generate a height map.
A height map?
Yeah. Imagine a massive grid of numbers where each number represents an elevation point. To drape a road, the AI has to write code that calculates Bezier curves.
Like smooth lines.
Exactly. Smooth lines. And then it mathematically intersects those curves with the elevation numbers of the height map. It is calculating the exact slope and vertex adjustments needed so the road doesn't, float in the air or clip underneath the dirt.
So, in less than 12 hours, CityLife went from a totally blank slate to a functioning mathematical city with an economy, zoning, jobs, left-driving traffic, and procedurally draped roads.
Pretty much.
But hold on, I have to challenge the premise of all this. A human brain cannot read, process, and approve that much complex mathematical code in a single afternoon.
Oh, absolutely not.
Right, because if a human tries to review every line to make sure it doesn't break, the whole 27-day timeline just completely falls apart.
You've hit on the central bottleneck of AI development right there. If the human tries to be the coder of record, the project stalls out. The human simply cannot review every line.
So what did he do?
Well, Irwin realized almost immediately that he couldn't just have one massive AI spitting out code at him. He had to build a system where the AI reviews the AI. He had to create a fleet.
Here's where it gets really interesting, because the source material lays this out exactly like a traditional corporate org chart.
It really does.
If Irwin is the CEO handing out the high-level tasks, who is actually hammering the digital nails? Like, what does this workforce look like?
It's a cast of highly specialized AI agents. And Irwin actually gave them names, distinct personalities, and very strict siloed lanes of responsibility.
They aren't just normal chatbots, right?
No, not at all. These aren't your standard chatbot windows. They are independent programs running on their own dedicated servers.
Okay, let's meet the cast. First up, we have Jack. The source says Jack handles the world and the build, specifically the 3D asset pipeline using Blender.
Yep, Jack is the 3D guy.
But how does an AI use Blender? I mean, it doesn't have hands or a mouse to sculpt 3D models.
This is a brilliant workaround, actually. Blender, the 3D software, has a Python API. That means it can be completely controlled through text-based code.
Oh, I see.
Yeah, so Jack doesn't sculpt a house visually. Jack writes a highly complex Python script that, when executed inside Blender, mathematically generates the vertices, edges, and faces of a 3D house.
Wow.
It applies the textures and exports the final model right into the game engine. Jack is essentially a mathematician who dreams in 3D geometry.
That is just wild. But okay, if Jack is just blasting out Python scripts to make houses, someone has to make sure those houses don't, crash the game.
Right, you need quality control.
Enter the most critical agent in the entire fleet.
Mojojo. Yes, Mojojo is the merge gate. And this agent enforces the most profound rule of Irwin's entire process.
Which is?
Irwin, the human creator, the CEO, is completely locked out of directly pushing code to the live game environment. He never self-merges.
That is so crazy to me. He acts like a manager submitting work to his own employee for approval.
That is exactly the dynamic. When Jack or another bot writes code, they create what's called a pull request, or a PR. It's basically a bundle of proposed changes.
Okay.
Mojojo operates from a completely separate, isolated GitHub account. Its sole purpose is to receive these PRs, review the code for syntax errors, and most importantly, hold its approval until all the automated testing pipelines are green.
I like to think of those automated tests like a digital car wash that the code has to drive through. If Jack's new 3D house code breaks any of the brushes in the car wash, the conveyor belt just stops.
Yeah, good analogy.
Mojojo will absolutely not let that code into the live game.
And that mechanical gate is the only thing preventing a runaway AI from just destroying the project.
Right.
But, even if code passes the syntax checks and the car wash, visual bugs still happen.
Which brings us to the third agent, Floyd.
Yes.
Floyd is the day-night visual QA. And the reason Floyd exists is fascinating to me. The source highlights this very specific bug where trees in the game were turning completely black.
I remember that part.
But the automated tests Mojojo was running couldn't see the problem because they were checking the math, not the pixels.
Right. Automated code tests are essentially blind. They just look at the underlying logic. Floyd, on the other hand, loads the live deployed world on an actual machine and takes screenshots.
Oh, so he's actually looking at the game.
Exactly. But what makes Floyd specialized is that he doesn't just take a screenshot at high noon. Floyd advances the simulation's clock and captures the world across the full day and night cycle.
Because bugs hide in the dark. I mean, how does a tree just turn black when the sun goes down in a video game?
Well, it usually comes down to how the AI wrote the material shader for the tree.
Okay.
If the code relies purely on a single global light source, like the sun, it looks totally fine during the day, but the AI might have, forgotten to code an ambient light bouncing or moonlight reflection or emissive properties.
Oh, I get it.
So the moment the sun dips below the digital horizon, the math returns a value of absolute zero light, and the tree renders as just a black void. Floyd literally looks at the shadows to catch these oversights.
It is such a clever QA loop. And rounding out the team, we have Schoonveld. Schoonveld is the sandboxed pen tester.
The security guard.
Yeah. This bot has no write access. It sits completely outside the game and relentlessly tries to hack the network security, escalate its own privileges, and break into the game's authentication systems.
It's an automated red team, just constantly stress testing the fortress.
But running a specialized corporate structure of bots around the clock brings up a very real-world problem. Economics.
Oh, absolutely. The server costs.
Right. At first, Irwin had the team running on 20-minute timers. Every 20 minutes, Jack, Mojojo, Floyd, and Schoonveld would wake up, look around for work, generate code, and push updates. They were churning out something like 26 pull requests a day.
Which sounds like a developer's absolute dream until you look at the inference bill.
The inference bill.
Yeah. Inference is the actual computational cost of making an AI think. Every time these bots woke up and processed data, the meter was running. They burned through a week's worth of their computational budget in just a couple of days.
So it's like keeping a fleet of taxis running their engines in the driveway just in case you need to go somewhere.
Yeah.
The gas bill will bankrupt you. So Irwin pivots. He shifts the entire fleet from being timer-driven to task-driven.
Right, a much smarter setup.
The bots now sit completely dormant, costing $0, until Irwin explicitly hands them a ticket. The pace slowed down a bit, but the project finally became economically viable.
And if we connect this to the bigger picture, it reveals a massive lesson for anyone trying to manage AI. The safety and success of this 27-day sprint isn't in hoping the AI writes perfect code on the first try.
Because it won't.
Right, we know AI hallucinates. The safety is entirely in the architecture of the system. The mechanical gates physically prevent bad code from seeing the light of day. The human sets the direction, but the system enforces the truth.
Speaking of enforcing the truth, we need to dive into the architecture of the game itself. Because if these bots are prone to hallucinating, how do you stop them from building a chaotic, ever-shifting funhouse instead of a stable city?
You need ground rules.
Exactly. How do you bind them to a single reality? The source says Irwin used some incredibly draconian rules, starting with absolute determinism.
Determinism is the absolute bedrock of city life. The entire 608 by 608 height field, world-like, the placement of every single mountain, river, and neighborhood is a pure mathematical function.
Okay.
It all flows from one single seeded generator, specifically a Mulberry 32 generator using a default seed of 4242.
Let's break that down for the listener. The unbreakable rule is that there is absolutely no math.random or date.now allowed anywhere in the game's code.
None. Zero.
But if you're generating a vast procedural world, wouldn't you want a little bit of randomness to make the forests or the street layouts feel organic and natural?
Well, what's fascinating here is that while randomness feels natural to a player, it is a total nightmare for automated testing.
Oh.
Think about it. If you use date.now, the code generates a different result every single millisecond. If the AI pushes an update to fix a bridge, and the game generates a completely new random city layout every time you load it, how can you test if the bridge fix actually worked?
Because the bridge might not even be there next time.
Exactly. You can't isolate the variables because the foundation keeps shifting.
Okay. So by forcing the AI to use the seed 4242, Irwin is buying predictability.
Exactly. It allows for what we call headless testing. The bots can test the mathematical layout of the entire city in milliseconds without even needing a graphics card to render it visually.
Because the math is identical every time.
Yes. If the game breaks, they just input seed 4242, and the math guarantees they get the exact byte-for-byte city back. every single tree will be in the exact same coordinate.
That's incredible.
If the output hashes don't match perfectly, Mojoja knows the new code broke something, and the PR gets immediately rejected. It's the anchor that keeps the AI from drifting into chaos.
That makes so much sense. You have to remove chaos to test logic. And that actually leads right into the second golden rule, decoupling. The source emphasizes a strict separation of concerns.
Yes. In CityLife, the simulation engine, which is written in plain TypeScript, is the absolute source of truth. It manages the math and decides what is real.
And what about the visuals?
The 3D renderer simply decides how it looks. And the user interface, which is built in React, just puts a frame around it.
The source gives a brilliant example of this decoupling at the pixel level. Imagine Jack the AI builds a house on a sloped piece of terrain.
Okay.
The 3D renderer looks at that and says, well, a crooked house looks terrible. So
Right.
the renderer applies a little visual trick. It might lie to the player and render a flat concrete pad underneath the house so it looks level.
Right, for the aesthetics.
Exactly.
Mm-hmm.
But the underlying simulation's numbers, the actual mathematical slope of the height map, that never changes.
The visible mesh lies for aesthetics, but the simulation engine never lies. All arrows point out of the simulation, never back in. The 3D scene cannot tell the TypeScript engine to alter the slope. The user interface cannot change the core math. By building these impenetrable walls between the visuals and the logic, the game remains mathematically stable enough to run 24/7.
Which perfectly explains why they went to such extreme lengths for the game's economy. The game actually integrates with a real service called Cooker.
Yeah, this part blew my mind.
Great. The citizens walking around the city are actually Hermes bots acting as virtual consumers. Now, the currency they use, the city coin, is completely fake, but the banking rails it runs on are totally real.
They implemented a self-contained double-entry ledger that mirrors every single in-game transaction to a real back-end API service.
But why go through that much trouble for fake video game money?
Because a double-entry ledger means every single credit has a matching debit. If you buy a digital tire for your car, the money physically leaves your digital wallet and enters the digital garage's wallet.
It doesn't just like spawn out of thin air.
Right, it doesn't spawn out of thin air, and it doesn't just disappear.
So it prevents the AI from accidentally creating an infinite money glitch.
Precisely. If an AI hallucinates a line of code that accidentally gives a player 1 billion city coins, the double-entry ledger API will instantly flag that the debits and credits don't balance to zero.
And the transaction fails.
The transaction fails and the economy is protected. They treat this fake money with the rigorous architecture of a real banking app just to keep the AI grounded in hard math.
Okay, so let's zoom out for a second. We have this rapidly built, deterministically perfect AI-generated city. It has a bulletproof economy, procedurally draped roads, and a fleet of specialized bots working around the clock.
It's an engineering marvel.
But the obvious question is, why build it? What is the actual application driving all this incredible math?
And this is where the narrative takes a profoundly human turn. All of this massive infrastructure, these AI managers, these CI pipelines, they all exist for one deeply personal reason.
It's so cool.
It traces back to a DOS video game from 1989 called Street Rod.
Gerwin is building this entire sprawling digital metropolis for one core purpose, so that he and his brother can meet up inside the game.
Yeah. And to ground this even further in reality, Erwin's brother is currently building an actual physical car with his own hands. This digital world is meant to be a virtual mirror to that physical build.
The gameplay loop they designed using this AI fleet is incredibly specific. You log in and you open the in-game classifieds, you buy an absolute junker of a car, you pull it into your Need for Speed style corner garage.
And then you build it.
You build it bolt by bolt, just like his brother's doing in the real world, and then you just wait for the simulation to turn to night.
That day-night cycle that Floyd tests so rigorously. It isn't just for atmosphere. It's the mechanical trigger for the core experience of the game.
When night falls in CityLife, the neon lights come on. You pull your custom-built car out of your garage, you drive to a specific hilltop rally point overlooking the procedurally generated city, and you race your brother.
That's it.
That is it. That is the North Star of the entire 27-day sprint. Every single technical decision, the mathematical draping of the roads, the warm horizon glow, the placement of the gas stations, it was all answered by one simple question. Does this make the night drive with your brother better?
It completely upends our understanding of software economics. Historically, if you wanted to create a massive open-world game with complex lighting and vehicle physics, you needed millions of dollars and hundreds of developers.
And years of time.
Exactly. And because the cost was so astronomical, the final product had to appeal to millions of players to recoup the investment. It had to be mass market.
But Irwin's AI fleet essentially dropped the cost creation to zero. He willed a massive open-world game into existence for an audience of exactly 2 people.
The barrier to creating bespoke, hyper-personalized AAA-scale software has essentially vanished.
If you're sitting there listening to this, think about your own hobbies or your own workflows. Imagine spinning up an entire software ecosystem just to automate your meal prep, or organize your garage, or recreate a childhood memory, simply because AI has made the act of coding practically frictionless.
That's pretty inspiring.
Let's recap this journey. It started on May 30th with a Genesis commit. Within hours, a mathematical city was born. Irwin realized human oversight was a bottleneck, so he built the corporate fleet. Jack scripting the 3D world.
Mojo Joe guarding the gates.
Floyd watching the shadows to catch visual bugs.
Yeah.
Schoonveld trying to break in. They bound the AI to the unbreakable rule of seed 4242 for determinism. They built an economy on real double-entry banking logic. And they did all of this cutting-edge autonomous automation just so 2 brothers could share a night drive.
This raises an important question, and it's really the thought I want to leave you with today. We have just seen that if you set up the right mechanical gates, an AI fleet can build an entire functioning metropolis just to recreate one man's nostalgic memory with his brother.
Yep.
So, if you were the CEO of your own AI fleet, what incredibly specific, hyper-personalized world would you ask them to build for you?
Think about that. Picture yourself standing on that beach in Cape Town, looking out at the water, knowing that just behind you, your own perfect world is being constructed, line by mathematically perfect line, while you simply watch the sea. Thank you for joining us on this deep dive. We will catch you on the next one.